So this is our last section of this unit. I want to start by telling you this will not be on your test, but it is more or less kind of tangentially related to what we've been doing, so I thought it'd be kind of nice to include it. Plus, it's something that I know you'll definitely see as you move on in math if you take Algebra 2. So we're going to be graphing a linear, keep that in mind, a linear, but this time it's an inequality. So the difference is these aren't just going to be lines. There's more to it than that. And to kind of illustrate that, I need to go back to sometime early in middle school when you graphed on a number line. So when you graphed on a number line, you had the set of symbols that were less than and greater than, and then you also had the set that were the equal tos. You had a less than or equal to, and you had a greater than or equal to. So the ones that were underlined meant that your number could also be equal to the number that was over here. So on the ones on the left, the greater than and the less thans, your numbers couldn't be equal to 3. It could be less than 3, greater than 3, whatever, but it could never actually equal 3. The ones that were equal tos were the opposite. You could have, the expression that I have written here, x greater than or equal to 5, 7 works, but so does 5. I can have bigger than or equal to 5. So when you graphed these, right, the ones that were not equal to, you put this open circle on your number line, and then you shaded appropriately. So in this case, I want numbers that are less than 3, like 2 over here is less than 3, so that would work. I can shade kind of in that direction. And what you did was you shaded on your number line here, and then to show that that included all of the numbers less than 3, you put the arrow on the end. Okay. Similarly over here, I want numbers that are bigger than or equal to 5. So the way you showed that in the graph was you filled in your circle, made this nice big goose egg on your number line, and then you shaded appropriately there too. So numbers that were bigger than 5 would be like 6, 7, and 8. So you would shade in that direction. Now, I've had students in the past that got hung up on the sign tells you which way to point or which way to shade, right? My arrow points to the right, so I shaded to the right. Don't get hung up on that, because if I reverse this, that's still the same statement. I want the numbers that are bigger than or equal to 5. I still shade to the right, not the left. So don't get hung up on the arrows. Now, how this fits in with a linear inequality, it looks worse. It's really not that bad to graph if you can graph a line. If you can't graph a line, these are going to be kind of difficult. So the big difference is, our symbols here, we've got a greater than or a less than or equal to. How do you show the difference like we did back here? Open if it was strictly less than or greater than, and then you shaded in if it was greater than or equal to, less than or equal to. So the way you illustrate that in a graph is that you use a dotted line if it is less than or greater than, and you use a solid line if it is less than equal to, greater than equal to. So I'm going to do like a dotted line when I do this first one. The way you graph this, though, it's exactly like the lines that we've been graphing. That's why I pulled this in to do. So I'm going to start at 2. That's my y-intercept. And I'm going to use, let me make the lines a little bigger here. I'm going to start at 2, and then I'm going to count up 1 and 3 to the right to get my next point, and then do it again just for repetition here. Now, this is not an equal to situation. It is strictly greater than. So when I go to draw my line, use your line tool, I'm going to make just short little bursts of a line. I'm not going to do long, solid lines. I tried to see if you could change the settings on this where it was, instead of a solid line, you actually drew a dotted line, because I've got other programs that I can do that in. Now, there's the shading aspect. Like we did here, we shaded our number line one direction or the other. Well, shading the linear inequalities is actually a little bit easier, because pay attention to this. I want the y values that are bigger than this equation. So I want the bigger y values. So on my equation here, on my graph here, I'm going to just pick a color, and I'm going to shade in, and you can just kind of scribble here with your mouse or your finger or whatever. I'm going to shade in above my graph, right? If it had been a less than, if I want the smaller values, I would shade below my graph. On the right one here, y is less than or equal to negative 3 halves x minus 1. That is going to result in a solid line because it is an equal to. But I start at negative 1, down 3 over 2, down 3 over 2. But this time when I draw, I'm going to do a solid line because it's an equal to. Now, I want the smaller y values, so I'm going to shade or color, however you want to think of it, all of the values underneath or below my line. You don't have to shade this in completely. Just make sure you stay on the lower end of the line. Okay, so again, if you can graph a line, these aren't that big of a stretch from what we've been doing. You've just got to be able to, I'm going to skip those because those are in standard form. I'm just doing the slope-intercept form of these. So I will give these to you in slope-intercept form. You graph your line like normal. If it is not an equal to, if this is not underlined, it is a dotted line that you're going to try and draw. Just do the best you can. I know it's kind of funky. And then you shade either above or below the line depending on your symbol.